Hello. Good morning to all.
Yes, Rana sir, you must start now.
Yes, sir. Good morning, one and all present here. I, Dr. Rajvi Rana, presently working as an associate professor in Electronics and Communication Engineering Department, BVM Engineering College. Welcome you again in this FDP. It is my immense pleasure to introduce today's expert of session, Dr. Nagendra Gajjar sir. Currently, he is working as a professor in Electronics and Communication Engineering Department since March 1998 in Nirma University. He has an experience of more than 29 years in the field of teaching, research, and industry. He obtained his BE degree in electronics engineering from BVM Engineering College in 1990. So he is our proud alumni. And MTech degree in computer application from IIT Delhi in 2002. Dr. Gajjar obtained his PhD from Nirma University in 2013. He has published more than 15 research papers in the area of embedded and VLSI design in international referred journals and presented more than 30 papers in international conferences. He is guiding 3 doctoral scholars and he has successfully completed a funded research project for ISRO and working on a funded research project for DRDO. His research interests include VLSI signal processing, processor architecture, reconfigurable computing, high performance computing, and machine learning for embedded system. He is a life member of IEEE, IETE, ISTE, CSI, and ISRS. He has served as a chair, IEEE Communication Society chapter, Gujarat section from 2014 to 2018. So now I humbly request Gajjar sir to share his expertise in this session. Sir, I think your mic is mute, Gajjar sir. Sir, your voice is not coming properly. No, sir, you are not audible, sir.
Sir, your voice is not audible. So I suggest that you may use your mobile phone for audio and for presentation you can use computer. Not audible, sir. Sir, no audio. Sir, I think if possible, you can join using your cell phone for audio. It will be in your calendar. I have also forwarded the link for the session in your WhatsApp.
Hello. Now audible?
Yes, sir, audible.
Okay. So I'll
Little more louder if possible.
yes. I'll do that. Yeah. Just a minute, huh? Sorry for inconveniencing.
No problem, sir. No problem.
Very good morning to you all. I'm thankful to Dr. Bhargav Goradia, Dr. Rajveer Singh Rana, and BVM Engineering College for giving me opportunity to discuss about IoT as the systems of systems on ATAL FDP on Internet of Things. So we welcome you all participants for this particular new domain of technology, which is going to rule the next generation of the world. So in some 1 hour or so, I would like to discuss what are the new things that is going to happen in this particular field. And then I wish that I have seen that roughly 55 to 60 participants are there. So I request participants as well as the organizers to arrange them in a group of 5 or 6 people and do the practice of what I'm discussing in this 1 hour or so. So let's start with the presentation, and I request all of you, if possible, you can take a note of the key points, and maybe after 1 hour or so, I request all of you to possibly do the interaction and come out with a kind of Internet of Thing as the systems of systems. That's what is the thing. Now, as the organizers and the professors approached me, I have given the topic as a systems of systems. The reason was that nowadays we have to look at the things as a whole. right? Definitely we were looking earlier as a common, we started off engineering as a civil engineering, and then mechanical engineering, and then electrical engineering, and then we were having a sub branches over a long period of time. But now we are looking at that, how do we look into that number of branches of engineering get merged together, and we evolved a system or a mechanism where we make use of all branches of engineering to solve a complex engineering problem. So IoT is the upcoming technology which is going to help us to digitize and make the systems smarter. So we definitely developed Internet of Things as a kind of a mechanism which can be used to solve a problem. So now to solve this particular problem, we have to understand that what is systems, right? What is the system of systems? What is system engineering? And how we can make use of the Internet of Things to solve this particular solution as a system. So that's what I thought that let me discuss the topic, which is IoT as a systems of systems. So let's go through the presentation. Anybody feel free to ask the questions in between also, or you can ask me later on. But as I said, and I insist that in 3 days FDP, the organizers should give a kind of assignment or exercise to all the participants, where they come up with the kind of system which makes use of Internet of Things. So I'll be sharing my presentation now. Is it visible to all? Hello?
Yes, sir. Yes, sir.
Okay, okay. So let's talk about in an hour or so about the IoT as a systems or systems. So the today's agenda is what are the systems of systems? What is now we as an engineer always looking at that. How do we look at the definitions of the system? So what are the systems of systems? The IoT as a special class of systems of system, and it is perceived approach to developing an IoT system. So I know then and hope and understand that you people have studied about the IoT architecture, IoT protocols, the IoT stack, and so on and so forth in your first day. So we need to look into that, how an IoT system which we can develop, making use of the architectural understanding, the kind of a connectivity that is being provided by the IoT. Okay, I'd like to ask a question maybe to the participants, or somebody can ask, what is the projection by 2020? People said that this many million or billions of devices will be connected. Anyone would like to try?
It's approximately, sir, 20 billion.
Yeah, so they projected it as a 20 billion, and then they said that no, it will not be a 20 billion, but we'll be connecting a 50 billion devices by 2020. We have not seen the projections has been touched upon because of this pandemic era, but definitely the billions of devices are interconnected, and people are always looking at a kind of a mechanism which the future engineers will be providing to the world, that how the IoT systems will solve the problem of each and every domain. So I'd like to mention at this point of time to all the participants that why computer has evolved and it has been so popular. The reason is it is applicable to each and every branch of engineering, as well as it is touching upon the day-to-day life of each and every human being, whether it is a common man, whether it is a very low level farmer, or whether it is very high level scientist, right? The same thing is going to happen with the IoT, right? Everybody in the world is going to make use of the IoT directly or indirectly, and then they will be. So we need to look into the perseverance of that, how the IoT system is applicable in the different domain of the human life, as well as the development which is going to happen throughout the world. So that's what is and as I mentioned that we need to understand it as a system. So I'd like to answer the questions of the systems and the definition in the next coming slide. And then we talk about the architecture and engineering of the IoT, or we call it as a IIoT, or people call it as Industry 4.0. So it's an industrial IoT, or it is Industry 4.0 as a standard, and so on and so forth. So what are the challenges of the industrial IoT? And then the IIC reference architecture, which is a kind of, now we say that when the system becomes too big, when the platform is too large, we need to have the management. So sorry to say, but we engineers normally fail in the management aspects, and that's how one manager handles 50 engineers, right? So that's what is the change that we need to bring it into our study, that we need to bring it in our understanding, and we have to learn the management aspect also. So because we talk of the IoT as a technology, so the technology can be deployed, but the management of the technology is also equally important. So IIC stands for the Internet Industrial Consortium. So Industrial Internetworking Consortium, which helps you to provide a kind of a reference architecture where you look at from the business point of view, where you look at from the architectural point of view, you look at from the implementation point of view, the execution point of view, and so on and so forth. So we need to have some kind of architecture, and that's what we say that in the internet also we have a seven layers of the architecture. So if you have an architectural available, then you can make use of the implementation much simpler and in a managed way, so that you can do a layered kind of architecture, and you may have an interconnectivity for the purpose of implementation, as well as the unified. So for that, there is a mechanism at an international level. We all know that it is being referred as a standards. So that mechanism, we represent it by one of the group called as OMG, Object Management Group, and they have proposed the architecture for systems of systems as IoT, and that is a unified architectural framework, that's called as a UAF. I'm sure that I won't be having a time to touch upon the UAF, but this is the agenda for today's talk. And this is what all references I have taken from the IBM company, as well as the OMG group, the UAF architecture, as well as one of the company called as a PUC. So this is the presentation points I have referred from this 2-3 references. This is just for your reference. Now, what is systems of systems? So in the short, I'll call it as SOS. I'd like to have, this is a fun reference. What is the other form of SOS? Anybody would like to mention? Okay, I'll give you a hint. Now, when you are into a difficulty and you have to give a message, you say, I'm giving a SOS message to someone. What is SOS? Yeah.
Hello?
Yeah.
Sir, it's Save My Soul.
Yeah, it's a save our soul, right? Good, very good. So SOS is a save our soul, right? But we say it's a system of systems. So I have highlighted some key words over here by the bold representation. So SOS is an integration of a finite number of constituent systems. So it's an integration of finite number. So we say that I'm designing a system which will be a integration of finite number of systems. So I have a system 1, system 2, system 3, and so on and so forth. So that's how I'll be having a finite number of n number of systems which I interconnect, and that they are the constituent systems. Okay, so you can keep in mind all these keywords which are highlighted here, because at the end I'll say that you design a system of systems which make use of the IoT. Okay, and then you propose a simple example. I'll start right now here, because I don't want to give a lecture for the sake of saving a talk, but I wish that you learn the things at the end of it, that you design an IoT system which comprises of systems. A simple example is that I want to implement the Internet of Things for farming purpose, right? So in the farming purpose, I'll be not having only one system. I'll be having the system which is a harvesting system. I need a irrigation system. I need a kind of a plow, or say a system. I need a system which is transporting of my products to the market. I need to have a billing system. I need to have the kind of manpower management system. So we need to have integration of a finite number of constituent systems which are independent and operatable, right? So suppose I'm giving you an example. I have a system which is a farming system. So I have a human resource management system. It is independent of my transportation. It is independent of my marketing. It is independent of my managing the resources, right? So they are independent, number one. Number two, they are operatable, right? They can be operated individually. They can be, but definitely they need, which are networked together for a period of time to achieve a certain higher goal. So in my farming system, as I said, I may have a number of systems, right? So they are finite. Number one is finite, right? I need to integrate them. They are networked, right? They are operatable. They are independent, right? And it is together for a period of time. And this all thing is to achieve higher goal. Can anybody think of that, the farming system I'm talking of, what is the higher goal that we are looking at? What can be the higher goals? I'll instead of goal, I'll call it as a goals, right? Can anybody narrate 1, 2, and 3?
Higher produce with the higher yield with the lesser resource utilization.
So one thing is a higher yield.
Lesser resource utilization.
Yes, very good. Next.
Optimization of resources.
Optimization of resources. Third. What our honorable Prime Minister or
proper marketing
looking for.
Proper marketing
income or a wealth, farmer wealth is to be doubled, right? Doubled by 2022 or 2024, right? So this one particular goal will be having a sub goal of all these points what you people are talking about. So that is what we need to look into, that what is the higher goal that you are looking, and within that you'll be having the sub goals or sub objectives that you may be declaring. So this is what is the intelligence that we people are adding, or say we people as an engineer, we don't look at this, we look at the technology to achieve this, but we never look at these aspects, and these aspects are associated with systems. So SOS is, so can anybody, so this is what I'm, Bhargav sir, I'm going to request you that you can divide the groups into 5 or 6. I'm not sure how they can do the interaction through the Google Meet. You people can create a group, have a Google Meet, and look into the different kind of areas for.
Sir, we have designed one assignment in this manner, and we are going to give at least couple of days.
Right. So farming application, then we can say a water resource management, right? We can say traffic management, right? We can say my digital manufacturing mechanism. So these are some of the areas, and where you have to identify and clarify with the clarity, you should say integration of finite number of systems. So for my IoT as SOS, I will be having, you say that within my system, I have a 7 or 8 independent operatable constituent systems which are networked together for a period of time to achieve a higher goal. So for each of them, you should give an answer that I have a 7 or 8 systems. I've integrated them in such a way they are a constituent systems. So what are the constitutions? So what are the expected outcomes or objectives of that systems? We should narrate it out. We should say independently they can work, right, with a kind of a parameters that is to be given for the control purpose. What are the operating conditions or operating mechanisms for that kind of systems, how it is being networked, and for what period of time. If I say that I'm doing it for in a farming, I'm doing it for a Rabi season or maybe the other season. So that is the period of time for what duration the system is integrated and interconnected, and what is the highest level of goal for that particular system. So if we can define this, then I can call that I have designed a system of systems, or say I'll be having a systems of systems. There are possibly that we may have a hierarchy level for achieving such kind of a goal. I hope I cleared the definition for systems of systems. Once again, I reiterate it. It's an integration of a finite number of systems. So for your application or the exercise or assignment that you look into, you try to classify once again that how I have integrated, what are the finite number of constituent systems. You can narrow it down the 1, 2, 3 number of systems. What are their major objectives of the systems, the outcomes of the systems, what is the input to the system, what is the output to the systems, what are the circumstances or environmental relations which I need to mention or manage, equipments, tools, and technology. So this is how we can narrate about the operating conditions. And then about the networking of it, how they are networked, what are the kind of input parameters I have, what are the kind of output parameters I have from that systems. So these are all things detailing that we can do it, and then we can define a period of time, that what is the duration, and we can create a kind of a concept called as a Gantt chart or a time diagram, and so on and so forth. So these are the kind of tools that we need to understand and take it for granted for designing systems of systems. Okay, so let's look at 3 other reference definitions for the systems. So one is a system versus systems versus enterprise versus systems or systems. So this is what is missing in our engineering domain, is that we study a lot of core courses, we study a lot of applied courses, we study a lot of elective courses and cross-domain courses also. But we miss one part of it, which is a systems engineering, which is a kind of a combination of interdisciplinary aspects. So suppose we say that systems engineering is like specifying a building or specifying a swimming pool. So that's how the things are being narrated, how the things are being incorporated to achieve a one specific goal. So that's what we call it as a systems engineering. Whereas the enterprise architecture, EA, is like urban planning, right? So we have a number of different systems. We have a number of different aspects to be carried forward, and we need to support them. So that's what is being referred as an enterprise architecture. Okay, so a simple example is, suppose another example if I would like to say is that if I have to design a kind of a process industry in which I may be processing a specific one part of a chemical to be manufactured, right? So it's a kind of a system engineering, because I'm manufacturing a certain chemical only, right? Or say I'm having some kind of a product to be developed. So that product mechanism that I can take care of. So these are the kind of things that we define it as a systems engineering. In the enterprise architecture, we say it's urban planning. So we need for swimming pool driven by council or government health objectives. The swimming pool is only the part of the solution, but whereas I need to reach the objectives such as running track, cycle lanes, need to integrate these solutions into existing services. This is one of the very, very important thing when we are proposing IoT as a solution, right? I need to look at that. I need to provide the solution into existing services. Because suppose say, let's take our light system, right? Street light system. If I have to do a IoT connectivity or IoT to be introduced, will I be replacing my existing street light poles? No, right? So I need to develop a IoT mechanism. Recently, I don't know whether you have heard of not, but normally we have our the traffic light systems, right? They are on from suppose say morning 6, say morning 8 a.m. to maybe late night 11 p.m. After that, it is turned off. So, or say during my 8 a.m. to 9 a.m. during my this pandemic era, even if my traffic is less, my traffic light system will be on because it is programmed and timed accordingly, right? So if I want to create a new IoT based system, will I be replacing my existing traffic light system? Not at all. I need to develop a mechanism which is making use of the solution which looks into the existing services. Can anybody give an example of such kind of a problem where the existing services are there and I need to look into the solution which is existing services, but I need to make changes into it? Yeah.
Smart electricity metering.
Very good. Any other?
Sir, we have astro timers in electric poles.
Okay, good. Yeah. Anybody other than this?
Smart panchayat.
Okay. Yes. Okay. So basically, as I said, is a provide service infrastructure to support and maintain them. So that is what is you need to look into, that my service infrastructure. So then what will be my requirement of the service infrastructure? It is not always, here I want to mention that it is not always hardware. We as engineers, we always, and particularly from circuit branches, we look into the hardware aspects only, but we need to look into the software. We need to look into the management aspects, right? And we need to look into the networking part, as well as we need to look into, I'm not talking of the networking from hardware point of view, but from the systems point of view and the data transfer point of view, or my data flow point of view. Okay. So these are some of the aspects we need to take care while providing a service infrastructure to support and maintain them. So EA that we mean by is EA is about managing and developing the systems of systems, right? So this is what we are looking at the aspects. Okay. Anybody, any questions till now? Hello. Okay. So example, as I mentioned, is a traffic management case study scenario. If you look at it, so we need to look at trip preparations, that how my trips are being prepared. Suppose if I am having my regular bus system available, right? And then transportation systems available. So whether it is my local transport, whether it is my taxi transport, whether it is my metro transports, and so on and so forth. So city traffic, we need to have interactions with the other autonomous cars, interaction with the pedestrians, and overtaking situations. So this is what is the mechanism which is nowadays existing is in the form of ADAS, that is automatic driver assisted systems. And in ADAS, we have auto driving systems. We have a level 1 to level 5, right? So this also you can take it as an exercise. Those who are interested can look into what is level 1 and what is level 5. Level 5 is a fully automatic mechanisms, and that's how we have a kind of a protocol being developed into mechanisms is called as a V2X. So we have a vehicle to vehicle, vehicle to pole, right, vehicle to the control centers. So these are the different kind of protocols available for the purpose of ADAS, and that's what we mean by is a V2X. And there we have a very strong use of IoT, the sensors, right, such as the LIDAR, your microwave representations, your sonar representations, right? So these are the different kind of platforms which are being used for the purpose of IoT communications or a networking with a kind of a protocols as well as the hardware and so on and so forth. So this is one thing. Okay, as the point has opened up, I'm jumping a little bit. Now people talk about a lot about the 5G. So what do you represent with reference to 5G? 5G is for my communication reference on the mobile. Okay, what is the major technology of 5G? Anybody would like to try? Yeah. Yes.
So the communication is pertain to the 5 gigahertz band. So the faster data transfer.
No. 5G is a 5th generation. My bandwidth allocation all depends upon the spectrum allocations from the people. But a 5th generation representation, 5 gigahertz definitely will be there as one of the spectrum, but it all depends from the company to company as well as from these people country to country. Yes. Any technological representation? Anybody? Yes. Okay, so I'll give a hint. It's a MIMO, multiple input, multiple output. We have a MIMO technology, so we have a multiple antennas, and using the multiple antennas, we achieve the higher data rate bandwidth. Okay. Now, by achieving a higher data rate bandwidth, we say that okay, right now my speed of download is up to say 10 or 20 Mbps only, right? But if I want to increase it to 100 Mbps, then with the same antenna, it's not possible. So what we do is we do a parallelism. We have a multiple antennas at the transmitter, multiple antennas at the receiver, and I can do it. So, but this is one hardware technology. So if we talk of the 5G, my hardware technology is just 10 to 20%. The rest all is my software mechanism as well as my management aspects, which allows me to make use of my spectrum efficiently. my spectrum efficiently, and my resources in multiplexed way. Now, this is all management, right? And that's what is to be reflected when we design the systems. So whether it is autonomous parking, my public driverless taxi, or my PDL back to the airport. So who will be doing all this management? So you will be having a kind of IoT platform, and you need to design a system of systems. And that's what is one of the important. The private car comes home, right? Can anybody give example for this? Why the private car has to come home? Yes.
After the airport drop.
Yes. So if I'm going to airport, I'll be doing my self-drive, and then the car may come back to home so that the other people of my home can make use of. So these are some of the, in today's age of IoT, smart systems, right? The only thing is that how you have a creative idea, solution, but the important part of that solution is the implementation. And in that implementation, we need to look into the different aspects of my systems to be deployed. So that's where it is very important that we look into the IoT as a solution, but IoT alone as a solution will not work unless and until I look at systems or system building. Okay. Now there are 5 traits of systems or systems. Systems of system. One of the trait is my operational independence. That is, the constituent systems can operate independently from the SOS and other systems. So it's not always possible that I'll be operating independently. A simple example here it is. Here I'm saying it is a traffic management system, right? So as a designer, as a solution provider, I have designed Uber or Ola. They have designed a system. Are they independent completely? No. They are bound by government rules, right? They may be bound by my traffic rules. And my traffic rules and the government rules will be, because the Uber and Ola, they are providing solution worldwide. So they will be having the rules to be observed at a world level. So that's what is a geographic mechanisms will come into the picture. So they are, I say it is independent, but it is not completely independent. Okay. Next is a managerial independence. So as I mentioned, the constituents, devices, and infrastructure are managed by different entities. So that's what is very important, that different entities, different people, the different government mechanisms, they manage the things independently. Then we have evolutionary development. The SOS evolves over a time. So once I have designed my traffic management system, suppose it won't be lying for 10 years, 20 years, right? It will evolve over a period of time. Now, with every change, the overall behavior of the SOS will change. So whenever you do some kind of a changes into the system, then the overall system of systems behavior also will change. The third point is the interface needs to be maintained and keep consistent. So the good or a bad part of the systems are that I have the interfaces. I need to keep them consistently. That this will be my interfaces, and that interfaces will look, even if I change my box number 1 with my box number 2, but my box input and output interface interfaces must be same. So that consistency maintenance is also a issue. The fourth one is emergent behavior. So when the SOS changes, new emergent behavior can be observed, as for example, the changes in the traffic flow when the new streets are open. So this is also the kind of a question that we need to ask when we are designing our system. So this is what we call it as, that we need to keep it in mind. Keep it in mind, the advancement and the futuristic needs. I hope most of you participants are from the circuit branches only. So do you think that a company who is designing the processor or the
From even civil electrical as well, sir.
electrical as well, no issue.
Electrical, civil, mechanical.
Yeah, sure. So in every branch of engineering in general, we need to look into that. My designs which are being deployed, I need to look into futuristic aspects. That I have designed the suppose a car, right? So we can take it as a car, which is consisting of all kind of engineering built in inside. So we need to look into that. If I have to make changes from the futuristic point of view, I won't be designing it from the scratch. I need to make sure that I have the possibility of making the changes into the existing system and make it future ready. Otherwise, what will happen is that there is the time to design, the time to market is a very tough competition over a period of time. So if I'm lagging by 1 month or 6 months or a year, I may be losing something. That's what right now we people look into the vaccine companies, right? Everybody wants to be first to make themselves the first to be in the market. And the last one, as I mentioned, is a geographic distribution. So the degree to which the interaction and behavior of the system is widely spread or localized. So this is also to be looked into, that the system which I am designing, right? Suppose now you have designed an IoT system for the farming, and you have designed it from the local point of view, from the Gujarat state point of view, then you have a very limited market. But if you are thinking of at an India level, there will be a different aspects of designing a system as well as the IoT mechanism. Suppose you are designing it, please. Hello. So suppose I am designing it for Africa region, right? So what is the things which I need to take care? Anybody may give some idea? Geographic distribution, I am designing an IoT system for African region. Maybe some kind of medical system which I have designed for Africa. Just think of what can be the thing which I need to worry and take care if I have designed for Africa, or say if I have designed it for India, but for a rural terrain area.
The local language,
Okay, but I'm
Connectivity.
technical point.
Connectivity and all that.
Connectivity issues.
Okay, very good. What else? My IoT systems, they all are normally, the circuit references are being designed for going to use the power, right? But I know that within my terrain area, my power won't be available all the point of time, right? I won't be having the electricity available. So I need to design my system in such a way that it has a kind of degree to which the interaction and behavior of the system is widely spread or localized. One another example I would like to give of a system. Many of you from the government platform might have got a chance of being what we call it as officer into the election system, right? And in the election system, you have to have the ballot paper, which is a kind of a complete microcontroller, microprocessor based platform. So even there also, now they don't say that all the people who are being an officer, for them, presiding officers, they all are highly intelligent, right? They may be a kind of supervisor level people also. So they have defined a kind of a thing that, okay, if you have to do the process, it will be a clockwise. You need to do first this, second this, third this, fourth this. So they have designed the system in such a way that first you have to take on a clockwise. So your brain is always working in a way, even if you are in a pressure. Okay, I have to do a clockwise, first, second, third, and fourth. So that's how you don't forget. So we need to look into the interaction. That's what is a spatial branch of domain of ideology has come up, which we call it as a human computer interaction, right? We have HCI. So how do I design in the best possible way so that my human computer interaction or interaction with the system and the behavior of the system is widely spread or localized. So whether I am designing it at a global level or I'm designing at a local level. So these are the kind of aspects that you need to take care while designing the system of systems. And that's what we call it as a trait. But the trait is, it's not actually a trait, but it's a kind of a points that you need to think of before you design a system. So you need to give an answer, think over it, and give. So this is what I'm saying is that for your purpose, you take one system to be designed, and you start asking the question in your group members. Okay, what are the operational independence? What are the traits? What are the problems? How do we solve the problems? And what are the things that we need to consider and take care of? So classification of the system of systems. So one is a directed, acknowledged, collaborative, or a virtual. So SOS is created and managed to fulfill a specific purposes. The constituent systems are subordinated to the SOS. So they are being referred as a directed systems. Acknowledged systems. So SOS has recognized objectives, a designated manager, and resources for the SOS. So you have recognized objectives, you define different subsystems. You have a designated manager who will be managing all the subsystems, right? So that's how it is acknowledged. So the constituent systems retain their independence, and changes in the systems are based on the cooperative agreement. So when you are going to make the change into the one or the other systems, you will be cooperatively making a decision that, okay, I'm changing this way, then my interfaces for the other systems will change this way, and so on and so forth. So that's what we call it as acknowledged. The third classification is about, we call it as a collaborative. So the component systems interact voluntarily to fulfill agreed upon central purposes. So the collaboration is a kind of thing is within your team, right? You say that, okay, I'll be designing the input system, I'll be designing my output system. Somebody will say that I'll be designing my central system. Somebody will say that I'll be managing my resources. I'll be managing the resources for you. Okay. And one person will say that, okay, I'll be doing a documentation and reporting for you. So you have a component of the systems where you interact voluntarily to fulfill agreed upon central purpose. So you want to design a system, you have distributed your task, and you are working in a collaboration. So that's what we call it as a collaborative system. And the last one is a virtual one, basically the internet. So SOS lacks a central management authority and centrally agreed upon the purpose of the SOS, right? So SOS must rely on the invisible mechanisms to maintain it. So you don't have a manager, you don't have a collaboration voluntarily decided, but virtually you have a kind of mechanism where everybody is working independently, and you reach to the purpose of your system. So that's what we call it as. So we all know that nobody who is designing the internet, who is operating the internet, no one is there, right? So there is no central authority to manage, but definitely there are groups which are maintaining the internet, right? Or say designing the standards, the rules, and so on and so forth. So similarly, for my virtual SOS, I'll be having some kind of mechanism. So we have to decide that my system will be a directed system, acknowledged systems, collaborative system, or a virtual system. Okay, so we say that in terms of my traits, whether it is operational independence, whether it is managerial independence, evolutionary development, emergent behavior, or geographic distribution, right? Whether it is a director system, right? Acknowledged system, collaborative system, or a virtual system. So we have a level being represented as low, medium, or high. So when I say internet, it is all operational independence, managerial, evolutionary development, emergent behavior, and geographic. So internet is, by all means, it is high, right? Supply chain management, we call it as SCM, okay? Or another representation is my ERP, enterprise resource planning. So they will be having this. I have an integrated water treatment, supply, air traffic management, autonomous ground transport, military applications, emergency response, or airport. So these are some of the criteria, or so this is what I have taken it from the European Union DANCE project, the classification for the virtual collaborative acknowledged directive versus traits. So similarly, you can say that, okay, where is my system? What is the graph for my system? So this is also one of the assignment part of it, that you can say that your system will be having what kind of independence versus emergent behavior versus geographic distribution. Okay. Look into one of the other aspects of the US DoD system of systems. DoD stands for Department of Defense of the US. Okay, so SOS are typically composed of existing systems which are identified to address new or emerging user needs, often while these systems are continued to support the original users. So this is also, as I said, is that original existing systems are there, right? You have emerging user needs, and this is where I would like to give from the business point of view, the IoT, right? We're designing smart, oh, sorry. We are designing smart cities. We are designing, suppose say within the smart city, I have a smart metering system. Whether it is electricity or water, right? In these systems, address new or emerging user needs. So is there any need for this metering or not? Actually, electricity, yes and no. For water, also it is yes and no, right? By doing a water metering, it is going to give the advantage to the government and not to the user. But by doing that, indirectly, the user will be giving a support to the environment by observing the use of the water and so on and so forth. So these are the kind of a system. Sometimes they are not emerging as a user need, but they are emerging it as a user need of the government to manage the resources. In general, we say that IoT, as we implement, is going to reduce the human resource use, right? Suppose earlier we had a meter to be read by the person who was coming and home to home, and he was reading the meter. But because of the smart metering, now it is not required. And through the IoT, we all know that we can manage the show without the person. So actually, we have reduced the use of the human resource and reduce the number of jobs. But then you are beneficial in terms of doing the analytics of the existing available data and so on and so forth. So SOS evolution is based on the changes in these constituent systems, making these systems the essential building blocks of the SOS. So it's not that we were not having a meter reading system. Meter reading system तो था ही, right? उसमें आपने modification किया And now, even if you look at your bill, your light bill, you will say that you will be getting every 2 months a light bill, or every month you'll be getting that you had used this many units. And over a period, you can say that in my December 19, my number of units were this much, and in December 20, my number of unit has been this much. So you can compare yourself, right? That how much amount of energy uses that you have increased or decreased, and so forth. Or say, would you like to reduce your consumption, and so forth. So these are the kind of thing is that you have an evolution happening, and in that evolution, your systems which you are introducing are essentially building blocks of your SOS based upon your emerging user needs and the requirements. Okay, so what you have is basically systems are the SOS building blocks, right? So what you have is you need to have addressing requirements and the solution options. You have orchestrating upgrades to the SOS. So based on that, actually it will come down to this because you have a translating capability objectives. You are monitoring and assessing the changes. You have understanding systems and the relationships. Okay, you are developing and evolving the SOS architecture, and you have done a SOS performance observations. So you need to do this exercise when you want to design a new system. Existing systems are always there. You need to look into the new objectives. You need to look at monitors and assess the changes. What are the changes that you need? You need to understand the systems and then the relationships. Developing and evolving SOS architecture, very important part of it. And then you do the assessment of the SOS performance, right? So this is also very, very important, that what are the performance parameter of a given system. Okay. So let's look at how the things are evolving or things are changing. So if you look at, as I said, this is all presentation slide, the points I have taken it from IBM and PUC. So thanks to them. So we have earlier had a product only. So suppose this is a tractor. We have introduced a smart product. So within the tractor, I have introduced, suppose say the kind of thing is that how much diesel is being consumed. So we'll have a kind of a mechanism which allows me to do some kind of a data collection and analysis of it. Then we have a smart and connected product. So what we have is we have connected it to the computer or a mobile platform, and then we will be having a saving of the data. And now it is not only with the product, but it can go on a network representation. Then we have the product system created. Can anybody give an example in the car product system? Now we have, suppose say Honda or Hyundai, right? They have a kind of a car connect mechanism. So you are connected with the platform, and then all your analysis can be done. So similarly here, a product system. So I have a tractor, I'll be having a planter, I'll be having a tilters, okay, I'll be having a harvester, I may be having my transport system also connected over here. I may be having my my irrigation system connected here, and that's how I may be having my farm equipment system, which can act as my product system. Okay, and then I have a system of systems, right? I have a farm equipment system, irrigation system, weather data management system, seed optimization system. Within my irrigation system, I'll be having field sensors, irrigation nodes, irrigation application, right? And there I can, within the irrigation application for a specific kind of crop, I can program it and make use of it. Similarly, for my seed optimization, my farm performance database, seed optimization application. So depend upon my area or geographic location, I can look at my farm performance seed database. I may be looking at different kind of seeds to be used. I may do the experimentation on the same farm, and then I have optimization applications, right? So these are all a part of hardware and software together. Similarly, for the weather data, I have a rain, humidity, temperature sensors, weather maps, weather forecast, weather data application, and so on and so forth. So this is what is supposed to is being reported by the Harvard Business Review. So now you look into that, how much is the engineering involved? Engineering is comparatively very less, right? If you look at the systems, right, a management aspects is little more, that how we do the integration of the systems and so on and so forth. So I request that all of you whenever you look at your assignment or exercise, you look into and try to start with a product and make it to the SOS kind of. So that's how that this particular kind of a graph also will help you to do the evolution of your IoT being used as system of systems or systems of system in your application domain. Okay. So a common perception of my IoT is that we have a kind of a networking, right? If it is a home representation, I have a digital information, security, large collection, bulk of information, right? I have household connects to the internet, collection of things. I have a mobile platform. I have my home automation, electricity systems, everything we do with all kind of communication, connect to the clouds, RFID. So this is what we understand it as the Internet of Things, right? Okay. And you have already seen the Internet of Things architecture as well as the protocol stack day before, yeah. So if you look at a connected car example kind of thing is you have a designing and connecting the devices, adding the intelligence at appropriate level, design the backend systems, you have analytics, decision making, optimize the overall systems architecture, understanding and using the information gathered, and monetizing the information that you have gathered. So this is what is being done by all high-tech IT companies, right? Whether it is Google or Twitter or Facebook or Instagram, what do they do is they do the monetizing of the information that they have gathered the data from all of us at the free cost, right? So you have a constituent devices, we call it as agents or things. You have a communication infrastructure. You have the protocols for the communication. You have a IoT cloud, predictive analytics, and you have a mobile device. This is a new generation handy device, which is everything in a nowadays, right? Some student comes to me and say that, sir, I want to develop a system. I say that you take a smartphone of 5,000 rupees, which will be much cheaper than your Raspberry Pi or Arduino platform, and provides you everything, right? Why you want to reinvent the wheel? Try to make your system which is in and around your smart mobile platform. Another example is of washing machine, which is I think I'll skip it for the benefit of it. This is all people know that in Noida or say in UP or say in Delhi, they have already had a smart meter systems where similar to our mobile platform, you have to do a prepaid, and suppose you have charged for 1,000 rupees. As soon as your 1,000 rupee unit are spent, your power or light or energy to your house will be stopped. So that is what is the case. So energy traffic and tariff is also now going to be a predictive and variable. So you can decide that whenever my power tariff is less, that point of time, my devices, specifically the devices which are going to be used is not the time bound, can be used. So these are kind of a customer to industrial commercial domain, or say maybe in the home domain, people look at cheapest energy tariff to be used for the purpose of my heavy work or heavy load. Okay, so these are all part of the IoT as a system process. So this is one another example you can go through. Yeah. So some of the unique challenges for the industrial IoT, one is the ownership. No one owns all of it. Second is a social or a pervasive has to add value. No one is going to pay for the subscription to a service if it doesn't work well or offer value or fit into their lives without them having to really think about it. So whenever we design some kind of IoT application, if it is not working properly, right, you have designed a home automation system, but it has to be social, pervasive, should work well, should offer a value and fit into their lives without having them to really think about it. So these are the points that we need to keep into mind while designing it. So complexity and the dependency is magnified. So if you have designed an IoT which the person or a user has to think, mug up, right? So the people will not like it, because the layman who is using the industrial IoT is not that tech savvy. Okay. So security, safety, and industry standards are magnified. So this is also very, very important aspects whenever we look at an industrial deployment of any technology. So security is very important, safety is very important, and the industry standards to be observed are also equally important. Right? You have designed a fire safety system, but then you have to observe the industry standard and the government standards to implement that industrial IoT. Impact on the development and implementation and testing, that is working with other partners to deliver the complete solution. So this is also equally important, right? You will not be developing everything of your own. So you are dependent on somebody else to provide the solution. So that needs to be taken care of, which increases the burden on the development, devices, infrastructure, services, etc. So the devices and services needs to be upgradable, right? So you have designed the system, a hardware system. Now you are using the AWS, the Amazon Web Services as one of the platform, or you are using Microsoft Azure as one of the platform for the clouds and the analytics. Then you have to see that it has to be a scalable, right? And so on and so forth. Time to market is one of the key thing, as I said, is that now you provide a solution, but your solution is not scalable. You take 1 year to get the solution to be in the market. So this is also a unique challenge for the IoT. And always on, always connected has to always work without user interaction. So this is what is the challenge, right? We have a kind of a concept called as a Six Sigma. Heard of it? Anybody? Six Sigma?
Yes.
What is it? What is it? Six Sigma?
It's a quality and manufacturing standard.
So it's a quality manufacturing standards. In a layman's language, if I want to say that out of 1 million hours, I may be down by 1 hour only, right? So out of 1 million hours, I am down by 1 hour is a big kind of a quality of services that you are guaranteed, right? So that the consumers, users, the buyers of such systems will demand such kind of quality of your product, right? So if suppose, no, simple example, you are purchasing internet service, and then your broadband service is daily for 1 hour. If that service is down, then you won't go renew that services, or you will discontinue and hire the another ISP, right? So that's what is very important, that so the similar way, then you turn the median traffic controls in India into a smart traffic lights. We don't want to have a manual maintain this, right? You need to have a mechanism so that it is auto control, auto configured, auto managed, and my maintenance is not manual. So these are some of the Now, that's another simple example. So if I have to give more detail, now, if I have to do the configuration of my traffic points and observe, and I have to go to all the traffic crossroads to configure it, I won't like it, right? So in the industrial IoT, my plant is of in the 15 acre, right? My user or say the supervisor won't be going at every place, right? They want to do the maintenance right sitting from the control room. So these are the kind of challenges that we need to look into. Or say I should be able to sit in my control room and say that this particular sensor is not working, or there is a problem in this sensor. So I can directly go to the same way as if I have to give an example of farm, that my sensor of this particular location in the farm is dead. So that is the kind of thing that we need to look into while designing my IoT platform. So highly diverse use cases, we can only begin to imagine what is possible. Traditional development practices don't scale to this type of system. So my traditional mechanisms of system design won't scale up. So I need to design a foray of new business relationship that will need to be properly managed. So these are the new business styles and ideas that I need to work with. And the last one is a volume of data that will need to be managed, analyzed, and processed. So right now in today's age, data is not an issue, except a few datas of confidentiality, and that people work out with a new way and means of getting the data to play with, right? So data may be issue, but the volume of data is nowadays available. So sometimes we get a free services, but it's not actually free. We are paying by giving the data. So, but then the data is to be processed, managed, analyzed, so that it becomes information for all. So what is the solution? The solution is a framework. So you have a business view, you have a users and a functional view, you have an implementation view. So for business view, you have an enterprise architecture, you have a systems of system architecting, and then users, and for functional view, you have a SOS engineering. For implementation, you have analytics, software development, embedded software services, and clouds. So for that, there is a kind of a concept, which is, we call it as MBSE, which is a new thing which is coming up. It's a model-based system engineering. So it's a model-based approach to system engineering, typically used by, is a modeling language. So one of the modeling language in computer science, we call it as, for the object-oriented programming mechanism, we call it as UML, Unified Modeling Language. But for the system purpose, the same kind of a modeling language being used is called as a SysML. So those who are interested more in detail, you can explore this. So SysML is a modeling language that deals with the system complexity, enabling the unambiguous communication among interested parties, and so on and so forth. So I may have a kind of a system model which can be a complex. So I may have a software system, systems in general, electrical system, mechanical system, manufacturing system, analysis system, management system, marketing system. So using my system modeling language, I can create the different systems. I can do the interconnection. I can define my requirements. So we call it as a requirement sheet, right? SRS, specification requirement sheet, can be done. I may have a system context model can be designed. I may have a structural model. I may have a use cases model. I may have a functional model to be designed, how they are interacting, and so on and so forth. So the complex system cannot be designed in a simple way on a pen and paper. We need a kind of a software platform where we may have a different perspective of my system of systems. So whenever I'm designing my IoT, there also I need to look into this particular aspect. With this, I put a full stop over here. If we have a quick questions, one or two, I can definitely address. And I request the organizers and the participants to proactively, specifically to participants, that you create a team of 5 or 6 people, take one aspects of IoT and create a system of systems based on the kind of points which I have described to you all in this 1 hour. Thank you all. The forum or house is open for questions. Yeah, please.
Sir, in enterprise architecture, the role of 5G, in spite of being a 4G available, the parking automations, the cloud car or smart car feasibility is already there. So the role of 5G, except the faster packet transfer or faster bandwidth, how we will be justifying so that it have a separate technology trademark, so it cannot be elopes like the 4G elopes then 3G just for the faster data transfer. So 5G also should have some edge on that. What's your opinion on that?
Yeah, good question. So the point here, as you rightly mentioned, is as I also told you, 5G is not only the hardware technology for providing you the faster data rate and the faster communication. It is just 10 or 20%. The remaining 5G is going to be the kind of architecture framework which is for managing the next generation technology in terms of, as you rightly said, for parking specification, for my retail business, maybe for my transportation mechanism. So 5G is going to give a lot of framework platform for the services which are going to do a value addition into your communication infrastructure. So it will be maybe within a couple of years, because of the law and the kind of the human involvement is there. So ADAS is not coming. Otherwise, Tesla and the other companies, they have already achieved a level 5, which is a fully autonomous car system, but it is getting blocked because of the laws and certain concerns only. So in that case, suppose you want to have automated car network platforms or services, they may be a part of the standards as a 5G. Yeah, possibly. Or you also can propose on it may happen that 5G is deployed. 5G may be having a kind of agriculture framework available as a part of the standard, and you can use outright that platform for implementing the services for the agriculture. Similarly, can be a kind of education system. 5G may be providing a platform or a framework for designing your education systems. Possibly, yes. So that's what is the systems of systems, the independent systems, they will be merged, and then they will be saying that, okay, we are providing this framework where the communication, which is a high-speed communication, will be taking a benefit and providing the support to speed up the complexity or say reduce the complexity of the existing services or frameworks. Yeah.
Sir, there was a question from Mr. Jawahar. He is asking, in general, for any IoT application, what are the requirements? Nodes, gateway, middleware, cloud, and end user are sufficient?
So in general, I'll say that for IoT, to start with the engineering, we as a circuit branch people look at from only the hardware point of view and implementation. So definitely we'll be looking starting with the sensors and the actuators. Next level is our computation resources. Next level is our networking. After that level comes is your application platform, where application platform will be doing the connections either with systems or application domain connections, either will be doing it with my humans. So this is what is the kind of a layered architecture that we have. So what you mentioned about the gateway, the nodes, they all will be part of my networking. That's all.
Yes, any participants have questions?
Sir, I'm having one question.
Yeah,
May I?
Yes.
So this question is regarding an autonomous vehicle security.
Yeah.
And the question is how we can create our own research lab so that the vehicular, means autonomous vehicle, intra as well as inter-vehicular connections can be made over there. And what is the purpose for this? I want to search for or checking various inconsistencies or certain vulnerabilities, because the vehicle is connected to the different wireless technologies. So the chances of the attackers. Means attacks might be the one of the major concern about the autonomous vehicle. So I want to check various different malicious attacks on the network and trying to find out the mitigation or the rules to defend these particular attacks. So is it possible in a
Yeah, so
research lab?
because a good
Yeah.
question. So the point is, now once again, we look at from the different perspective. So we need to narrow down as you are talking about the security. So
Yeah.
one of the major mechanism that the people may enter into is intrusion, right? So
Yeah.
that's what is we need to look into the intrusion detection. Number one.
Hmm.
Number two, there are possibilities that as we are playing with the IoT and the hardware and software both. So the next level of security that always we are looking at is we call it as a hardware security. So
Hmm.
how do we provide the hardware security so that my instead of doing a software level calculations and providing my AES and DES kind of a standards for the purpose of security of the data communication. Definitely they are existing, the solutions are existing, but we need to look into the hardware security part also. And for the hardware security part, we have a number of different mitigation mechanisms available right now. I don't know whether you people are aware or not, but there are chances that people are doing a side channel attack. We call it as SCA. So by the side channel attack, they try to find out even your AES and DES keys. So to avoid that, we need to provide a kind of a platform. We call it as a hardware security or a boot level security. So these are some of the mechanisms existing. So what I suggest is that you can look into the scholar articles on hardware security. You can look some of the scholar articles on the intrusion detection and the mitigation. So that may help you. And to
Okay.
start with the purpose of lab, I'll suggest that we may start with the simple simulation level platform with the students and create a group in the and we look into V2V, V2X kind of a communication platforms and protocols. And the next level, if you have the funding available, you can look into some of the hardware platforms of sonar and lidar, which may
Hmm.
help you to start with.
Okay. Thank you, sir. And one more thing. Currently, what are the autonomous vehicle protocols currently using? They will be having various problems associated with them if I'm comparing with the bandwidth.
I'm not sure. I have not used or worked on any of such protocols, but as far as I understand, in implementation level and the commercial level, up to ADAS 3 is existing. So
Hmm.
you can look into the literature. What
Hmm.
is level 1, level 2, level 3, level 4, level 5. So up to level 3, it is commercially being deployed.
Okay. Okay. Thank you, sir.
Now, anyone questions from the participants? Okay. So
Thank you, everybody. Thanks a lot.
thank you very much, sir. A very informative sessions on IoT system as a system. And behalf of BVM Engineering College EC Department, we are also thankful to you for these lovely sessions and informative. Thank you very much, sir.
Thank you, everybody. Thanks a lot.
Now, dear participants, we are sharply meet on 1:30 for the next session. Thank you very much, sir.
Thank you.